For those of you who were here when we started the workshop and I had my introduction and welcome, um, I have for the last year with my colleagues been involved in a national AI engineering study where we talk to experts in machine learning and AI. We had speaker series where people came in and talked to us about their perspectives, and then we did a lot of reading and research in this space. So what I'm going to do to present here is kind of my perspective and some takeaways from this last year of understanding more about AI engineering and particularly data engineering. So I'm going to start off the presentation by talking about trends as I see them in AI and machine learning, and then how those trends connect to potential data quality challenges. And then at the end, I'm going to talk about some areas where I think there are probably future directions of work or things that are becoming increasingly important given some of these trends in AI. So first, an obvious trend is that data sets are getting larger. There's now an exponential growth in the data points used to train AI models. And this may be fairly obvious, but of course, significantly more data means there's more data to assess. Therefore, it can be harder to identify quality of individual samples. It also means that there's larger computational costs for evaluating model performance on data sets, which makes this more challenging. The next trend is that model behaviors are getting more complex. So this plot here shows year on the x-axis, and then the y-axis shows the length of time it takes a human to do tasks that AI can complete with a 50% success rate. So here you can see, in previous years, it could do tasks that humans might do in a minute. Now, models are able to perform tasks that humans might do in an hour. So this is kind of a proxy for showing that models are performing more complex tasks. And this means that more challenging tasks makes it more difficult to determine and assess what makes data good. It may not be easy to just identify certain features that should be in certain realms of values. So that can be more challenging. It can also be difficult to determine what data covers the desired behavioral characteristics. The next trend is that, and this is very good coming after the last talk, but AI is saturating on benchmarks. So this plot shows again year on the x-axis, and on the y-axis shows the performance of models relative to human baselines on a set of benchmarks. So interestingly, here on the right side of the plot, these show some of the more recent benchmarks that quickly AI models are getting very good on the benchmarks and exceeding human performance. So if benchmarks are starting to saturate, that makes it more difficult to assess the limitations of performance and gaps in knowledge. Another trend is that there's likely going to be a significant increase in AI-generated data for two reasons. One is naturally because now users are creating more AI-generated content because with the introduction of these more powerful models. But also there's this trend that's shown in this plot, which again shows time on the x-axis, and on the y-axis, the effective stock of data in number of tokens. The blue line here shows the data set sizes used to train previous LLMs, and then sort of the trend of anticipated data required for future LLMs. And then in the green shows the estimated stock of human-generated content over time. So this analysis finds that in the next few years, we'll get to a limit where models will reach a limit of human-generated content. So this presents new and unique challenges because it may be hard to ensure that AI-generated data accurately reflects the real world. And the impacts of retraining models on lots of AI-generated data are still not fully understood. The last trend here is in this recent years, more and more AI models have been trained on data from public sources. This shows, for example, tables about the data sets used to train GPT-3 or Olmo-2, and I've highlighted the data sources which have contributions from public data that individuals can contribute to. So this use of public data can introduce vulnerabilities to data poisoning, where some bad actors may insert some problematic data that can create unintended or I guess adversarial connections between inputs and outputs. It can also be biased data, and using more of this public data that users, like individuals, can contribute to may reduce trust in the training data overall. So with those trends in mind, now I'm going to talk about, as I mentioned, some of the areas in which I think there are future directions in developing best practices and new AI engineering techniques. So first is efficient methods for evaluating data quality. Um, in talking with experts in this field, I've heard several people mention that they assess data quality by observing the performance of the model. So they will take a set of data, and I wouldn't say exclusively they do this, but this is a major way in which they determine whether their data is effective. So they have a set of data, they use that data to train the model, see the model performance, and then say, oh, maybe this isn't what I want. They go back and update the data. So for simpler data sets, simpler models, that feedback loop may be fast and effective. With more data and larger models, this loop becomes quite slow, and it can be hard to determine data quality quickly. This also is sensitive to evaluation data. So I think we've had various references to this throughout the talks today. But if the evaluation data has similar errors that the training data has, then you may be missing errors through doing this method. So the future directions in this case are to develop more methods for assessing the various aspects of data quality that could be proxies for ultimately how the data is going to perform when a model is trained on it. So the loop can then look like data is assessed for a certain level of quality. If the quality is not deemed to be appropriate yet, then it can go back and data can be updated. Once the data quality is deemed to be a certain level of quality, then it can go on to train the model. Of course, this happens now, just seeing that moving forward may become increasingly important to create more of these techniques. And as we've talked about today, it's important to have humans in the loop on this process to be able to assess characteristics of data quality that may not be obvious in automated methodology. The next technique here is techniques for identifying gaps in data. It's difficult to know what a model doesn't know. And more complex data can make identification of gaps more challenging. Interestingly, we also have heard about identifying gaps in data today. So this is great, helps move in this direction. The other piece here is that data can have long tail distributions. So there may be rare events that are not likely to occur in training data, but represent gaps in the operational domain, which have really big safety concerns. So the future directions here would be to develop techniques for identifying and filling gaps for these data sets. And importantly, this includes filling gaps for the training data sets to make sure the trained models learn how to perform well in all instances, and then filling gaps in the evaluation data set to make sure that the quality of the model is being assessed across the variety of settings in which we expect the model to perform ultimately. The next is implementing data curation strategies. So as data sets are becoming larger and more complex, both it's quite costly to use an entire data set, but also many of these large models are using similar large data sets. And this may mean that there are approaches that could both improve performance by identifying what the most important data is, and then also more efficient by reducing the requirements for data. So these data curation strategies could include pruning to remove problematic samples, or core set selection to identify samples that are most informative, or active learning to actively select which samples can be used, plus other techniques as well. So the future directions here would be to establish practices for determining which subsets of the training data may lead to both model improvement and computational efficiencies. The next piece is making sure we're intelligently incorporating AI-generated data. As I mentioned in the trends, there are two sources that indicate that we are likely to see more AI-generated data in data sets. both because synthetic data may be necessary given the limit of human-generated content, and also um, more users are employing AI to create content. So there's this popular piece of work that showed that as models are trained on more model-generated data, they end up having model collapse, which can create significant concern. Notably, this initial work had an assumption for most of its analysis that was that the initial model was trained on real-world data, and then that model was used to create synthetic data. That the second model was trained entirely on the synthetic data, and then used to create data set three, where the next model was trained on just that synthetic data. So in this case, they observed model collapse. However, there's been other work that shows that when you incorporate real data, um, in addition to the AI-generated data, the model collapse is not as apparent or non-existent. So I think this area is still an area open for both research and for engineering techniques, for developing data curation techniques, but targeted at filtering out the AI-generated data, which can have negative performance. And this relates also to some of our conversations today around biases. Of generated data. Is the generated data going to start to bias what a model looks for and generates? And then in future iterations of models trained on that data, will those biases be increased? The next piece here, after mentioning how much public data is used to train large language models, there's a really interesting new piece of work out in this space. And first, to contextualize this new work, in the research area of data poisoning, as I mentioned, the assumption is that adversaries will insert some sort of poisoned data into a data set to create some adversarial effect in a model trained on that data. Typically, in research and data poisoning, the amount of poisoning is communicated as a percentage of the total training data set. So let's say 1% of the data set is poisoned, and then that creates a certain effect. However, this most recent work showed that a fixed number of poison samples can effectively insert poisoning into models of increasing size with increasing training data set sizes. So this plot kind of shows this result. On the x-axis here are the expected poison samples seen during training. And on the y-axis shows the perplexity of the generated data. And this is a proxy for attack success rate in this paper, because the goal of the poisoning technique is whenever a trigger word is present, it causes the model to create gibberish, which has higher perplexity scores. So what we see here is all of these lines are different models with different data sets, including, so going from 600 million parameters to 13 billion. And all of these show an increase in the perplexity of outputs when the trigger is present, which is an increase in the attack success rate, for as few as 250 poison samples. So when we're thinking about this in the context of traditional data poisoning and how it's communicated, for the largest model, this is equivalent of 0.00016% of the training tokens being poisoned and causing this adversarial behavior. So this is a suggestion that there can be a pretty big impact on models from a pretty small set of data. So you can imagine in this case, maybe there are bad actors that want to insert something into a model, but they don't have to be bad actors either. You could imagine companies would want to put out data that would cause models to compliment them and say they're good, or individuals may want, their resumes to look good or something like that. So now that we're in this domain, where it's known that models are possibly training on sets of public data, many actors may want to put data out into the space to change how models behave with respect to certain inputs. So the future directions here are really to develop methods for identifying evidence, certainly of poison data, but maybe any sort of data that's unexpected, and then remove these problematic samples. And I think the last piece I have here is assessing data quality for complex data. More complex data has hard to define success criteria. And I think, again, it's great that this comes after the talks earlier today with rubrics and other ways to translate what humans know into how we define success or quality of data. But it can be hard to create effective benchmarks on these tasks, so therefore hard to assess data quality. But importantly, and I think this aligns again with what we've heard today, incorporating human expert oversight into this process is very important. So both we want to create processes that allow humans to better understand the characteristics in data, and then also tools for which humans can more efficiently interact with data. So with that, those are sort of the points I'm looking to make, and I can take a look at Q&A if it is up. Um, so this one says, in terms of assessing data quality, what's used as ground truth? Is it some human judgment or how well the model performs? Is that ground truth? Um, yeah, so I think oftentimes labels for data sets are intended to reflect human judgment, because you want the models to be performing in a way that aligns with how humans expect them to. So I would say traditionally it is human judgment that creates the labels, um, and then the labels help contribute to the assessment of model performance. Well, let's see. If there are no more questions, then that's the end of our schedule today. I want to give a big thank you to all our speakers. I think it's been great to get perspectives across research and production level inputs, and both looking at different models across the spectrum of complexity. So I'm really, really thrilled with the amount of information we got today. As I said, I'm hoping it creates a conversation in this space. I think it's an important space with a lot um, more to do. And so thank you all so much. Feel free to reach out if there are questions. And I think that's it.